Hello, today I'm going to solve this interesting integral from the MIT integration bee. Well, it's actually a limit of an integral, so let's get right into why this is kind of complicated. So we're going to get n times our integral, and n is going to go to infinity, and our tangent of x between 0 and pi over 4 is going to go to 0, especially when, of course, we take this limit to the nth power. So tangent of 0 is equal to 0, and tangent of pi over 4 is equal to 1. We basically have this 0 times infinity situation, and we have to deal with that using some tricks. So we've got this nth power in our integrand, and we're going to get rid of that immediately just by doing a substitution and trying to, take that nth power out of the integral. Otherwise, we're going to run into some issues. So we're going to have tangent of x to the nth power is equal to, let's say, u. So first of all, I'm going to take the nth root of both sides. So we're going to have tangent of x is equal to u to the power of 1 over n. And of course, we can now also take the inverse tangent of both sides to get x is equal to the arctangent of u to the power of 1 over n. So we have this, and at this point, we're just going to find our dx. So we have 1 over 1 plus u to the power of 2 over n, since we square it. And now we have to apply the chain rule. So of course our function we plugged in was u to the power of 1 over n. So that's just the basic derivative, which is going to give us 1 over n times u to the power of 1 over n minus 1, and then of course in the end du. But of course this looks horrible. So we'll quickly substitute it in and see what we can clean here. First we need to look at the bounds though. So basically when we have tangent of 0, we have 0, so that bound stays the same, and then of course 1 to any power is also just 1. So of course we have the limit as n goes to infinity of n times the integral from 0 to 1, and then tangent of x to the power of n is going to be u, so we have u times our dx, which is going to be 1 over n times u to the power of 1 over n minus 1 divided by 1 plus u to the power of 2 over n. Okay, so as I said, this looks horrible, but the first thing we can immediately see is this n and 1 over n, which are going to cancel out. So that's really nice, because that also helps with our limit. And then, of course, we have this u to the first power and this u to the power of 1 over n minus 1. So we can cancel this minus 1 and this u to the first power as well. Now, actually, we don't really have an improper situation anymore, since both of these limits are fairly simple. So let's look at what we have. So we've got the limit as n approaches infinity of the integral from 0 to 1. And then we have u to the power of 0, essentially, because we have 1 over n. So if we take the limit, we have u to the power of 0, which is 1, divided by 1 plus, and again, the same situation, 2 divided by infinity is also 0, which is going to give us 1 again. So we have du. Of course, we don't really need our limit in this case anymore. And all we have is 1 over 1 plus 1, which is, of course, 1 over 2. And this is a really simple integral, which is going to give us 1 over 2 times u evaluated from 0 to 1, which is going to give us 1 over 2. So thank you so much for watching. And till next time, I hope you liked the video.